gone past the limit. True. Should remember that. Oh, and we're recording already. Here we go. Bring it back to lesson time. Oh, thank you. Double angle formula is going to be related to what we did yesterday. So if you felt comfortable with our trigonometric add and subtract formulas, then this is just adding on to that. For instance, if I was doing a double angle theorem using my trig add and subtract, if I had the same angle, A and A, right? Then we get into the situation where we have 2A, right? Whatever it is. If this is pi and that's pi, we'd have 2 pi. So basically, we're going to use these same addition, subtraction, sine and cosine start out functions here. And some of these actually are derived from what we're going to get here. But to start out in our basics, we're going to use the cosine addition formulas and the sine addition formula here. Everything boxed is where we're going as far as our 4 main formulas that we can use to approach these problems. The sine is this is the only one with sine, right? So when you have a double angle formula involving sine, or you choose to use sine, then you have to use this formula. But the otherwise, cosine of 2x has 3 different options, and that's where, based on the information, you'll choose from that. Okay, so let's look at this right up here. And this one goes pretty quick. Like I said, if we have the sine of x plus x, sine of x plus x, look what happens. Sine of x, cosine of x. I mean, just fill it in. Just changing all the y's to x is sine of x, cosine x. Wow, look what we have there. What do you see?
2 sine x plus, no, 2 sine x.
Those quantities are identical. So if it was, if this equaled 8 plus 8, you could express that as 2 times 8. Okay. In that same way, when we have 2 angles that are the same, which we're going to see, this is also a process of, if you are given an angle, you can break it up into, break it in 2, and from there, you have the double angle formula. Okay, so watch. X plus x, 2x. This here, sine of x, cosine of x, and sine of x, cosine of x. How can we express that if we're adding them together?
2 sine x cosine x.
Good. So there's nothing squared actually because we're adding them. But we're going to have 2 times the sine of x, cosine of x. Okay. So this is one of our formulas that we'd use. It basically is found by just having our angle sum, our addition formula, and just replacing it with 2 identical angles. Pretty straightforward. These proofs are like 3 steps, you see. So I'm going to let you play with this one. I want you to go in, and instead of it being x and y, make it x and x. Change this up and see if you could find how we're going to find, or how we'll discover our first cosine of 2x. So again, we're changing it to this, and I want you to work it out. Cosine of x plus x. And now what do we end up with? Let's check my notes real quick. Alright. This is going to come into play at some point. So I want you to keep in mind that Pythagorean identity that we had. And keep that in mind as we work through these. All right, yeah, it's really straightforward. So what are you seeing? What are you seeing? We end up with what? Cosine of x, cosine of x. Oh, sine of x, sine of x. Oh, we have some repetition there as well. It's within each quantity, within each quantity here. So how should I then express these 2, since it is multiplied, and they're identical? What do we do then? It's a squared value. So here we're going to go the cosine, and actually, I don't think we need this step because we're going right to the answer, but x, that's fine, we'll do it. So we end up with the cosine squared of x minus the sine squared of x. Because this is cosine of x times cosine of x, and with trig functions we establish it as cosine squared of x, so we don't get confused if we're squaring the angle. So that is where we arrive. X plus x, 2x. So we're going to go in here and get to the cosine squared of x minus the sine squared of x. So this is going to be helpful if you know information about cosine and sine. And when we do practice problems, you'll see how this all falls together. All right, let's see. We have two additional formulas for cosine of 2x. I'll take the question first.
So for the last one, can we factor x out and then just have cosine squared minus sine squared and then in parentheses x?
Not in this application. There's some PEMDAS rules that would prevent that. But in essence here, remember that x in this is talking about an angle measure. So we want to take the cosine of an angle measure. So in this case, this is done incomplete. We don't want to factor it anymore. And you couldn't factor those out because you can't. Well, no, can't. Because then we would just have x out in the front and it would be 1 and 1. And you could think about that. That wouldn't arrive at the same conclusion. It's out in left field. It's not the route. So, looking at this, two more formulas for cosine of 2x. Here we're starting with where we left off here, and we're converting it a little bit further. And I want you to take this. What do we have? We had cosine squared of x plus sine squared of x is equal to 1. I want you to keep this in mind. Is there any manipulation of this Pythagorean identity that would allow us to change this up for our own use? Change it up so we might use different values than we're given. What do you think? Could we solve for either of these and maybe substitute them in? Let's try this, play around with it. Let's try that. So for this one, which one should we solve for? Sine. Okay. Minus the cosine squared of x, minus the cosine squared of x. So we have sine squared of x is equal to 1 minus the cosine squared of x. Right? Just simple moving it over. So now we know what the sine squared of x is. So I want you to go in, and I want you to substitute it in here. And I think this one is just going to be a one-stepper. So go ahead and substitute it in. Questions? So one thing also to remember, when we get into this problem, we're going to really see it here because we can take the cosine of pi. We can do that. We can think of the unit circle and find it, right? We use this as example 1 that we're going to get to because we're going to solve it using the double angle formula, but we also already know the answer. Okay, so you're going to be able to see and check yourself quick. You could do that with any of these problems. Just know you have to solve it like this for the quiz and for everything else. This is the standard. This is not a double check with the calculator or unit circle, but we're going to break them up no matter what, even if we know what the value is. All right, who can tell me? What am I going to end up with when I take this? Put it here. We're going to get the cosine of 2x is equal to cosine squared of x minus 1 minus the cosine squared of x. Okay, clean that up. That negative needs to be distributed to that quantity. See what we end up with. Oh, there is a second. And then use what we did in the other identity to kind of help you see what you can do with this now. What did we do to simplify this before? Cosine squared of x plus another cosine squared of x.
2 cosine squared of x.
2 cosine squared of x.
Minus 1.
Minus 1. That's our second cosine of the double angle. Okay. Okay, so you can see the source of the two other formulas is just this first one, which was the Pythagorean identity, pretty much. So since you know this is our starting point, what was the other thing we could have substituted in? Right, cosine. And you guys agree that since it's addition here, we're just going to subtract it over. So you'll get the cosine squared of x is equal to 1 minus sine squared of x. There's no mystery in that. We know this is now the cosine squared of x, so I want you now to just derive the formula. Let's go ahead and finish it out. Get your third formula, fourth formula, and then we'll do an example. Cosine 2x is equal to thus. So this is within, we've done trig identities yesterday. That's these. These are really just trigonometric identities. So this is for adding and subtracting. Those are the identities. These are all double angle formulas. Again, additional identities. Kind of like the properties, inequality and equality. They're the rules on how numbers interact. These are the foundations for trig. So the necessity to learn them right now, it may seem, well, why don't we just do the cosine of pi? Why would we break into the cosine of pi over 2 plus pi over 2? The applications of that are actually a little bit further along. Right now we're just learning the basics. Okay, and you're going to have these memorized. So I'm actually going to challenge you for Friday for that quiz. One of the main parts is having these down. I'm going to ask that you memorize these 4, these 2, and there might be 2 more tomorrow. It's going to be the main part. It's a depth of knowledge 1, but I want you to practice just, can you memorize these formulas? I'm taking tests where you have to memorize like 20 formulas, 20 identities. So I want you to just practice that a little bit. How would you do that? I want you to get that method to do that. Flashcard, how are you going to do it? Quiz by someone else. Make a plan. All right, let's go ahead and make this 1 minus sine squared of x minus sine squared of x. So, what should I put in there? 1 minus 1 minus 2 sine x squared. Sine squared of x. All right, we have our 4 double angle formulas. If needed and you forgot one of them, you could derive it, because all of these are derived from this one. So you could have this and this memorized, and then derive these from them. It's just applying that Pythagorean identity. No problem for you guys and gals. And this is really binary. All right, let's be less binary. Cosine of pi. What does that break up into? If we're doing double angle formula, we know that just as we opened up here, it's x plus x. So what angle plus itself gets us pi?
Pi over 2.
Right. Cosine of pi over 2 plus pi over 2. Okay. So since this is the case, first off, let's think of the unit circle. Think of the unit circle. And that's a little better. All right, unit circle, pi is way over here. What is our x value, because we're talking about cosine of pi? What is our x value of pi? -1. So I know that this is -1. We're going to use this method right now to test it out and see how it works. So it's your decision. How many formulas do you have to choose from here for the cosine of pi over 2 plus pi over 2? How many different options do we have out of these 4?
No, 3.
3. This one over here, which we don't really need these pencils. That's clean. So this is the only one with sine. You know what you're doing if you have this. But here we have 3 other cosines. So which one, is there any one that you want to try, or we can just do, roll a dice, or is there a better?
In most of these situations, where you always be able to find the answer with any of them, but one of them is clearly easier. Or would you say there are some situations where you can only use one of the three? Or does it depend on what you've given them?
It's dependent on what you're given. I can't really give the example straight off because it's the design of the problem. I think with this one, let's see what we can do. I say we use one of the last two here. So let's throw it in. Should we use cosine? Yeah, let's do that. All right, so we have the cosine. We're going to find, 2 times the pi over 2. So our double angle formula here equals 2 cosine squared of x minus 1. Okay. So essentially what we're going to go here and do is 2 times the cosine of pi over 2. We're going to square that value in minus 1. Just like yesterday, this isn't a lot of calculator work because we're using the angles that are on the unit circle, and you have the ordered pair for each of those angles already. Okay. There's the unit circles all around everywhere. Now, what is the cosine of pi over 2? 0, movement along the x, so here this is 0, 1. So look what happens really quick. 2 times 0 minus 1, negative 1. So what we found was that the cosine of pi is negative 1. And we found it from the double angle formula. I made this one a really easy one because we already knew from the unit circle that it was negative 1. Now we're just practicing dividing up the angle and working it with these identities. Okay. I need to erase this. I want you to work on this one independently for a minute or so, and then double check with your neighbor that you're on the same track. It says if the cosine of theta is equal to 0.3, the sine of theta is 0.4. What is the sine of 2 theta? So the 2 theta is just talking about, in this case, theta is replacing x. Okay? They're both talking about an angle within that. So this one, I want you to look to see which of these do you want to use well. It's a quick look. Binoculars out. Take pictures. What is a sine of 2 theta? So really quick look tells us which double angle formula we're going to use. Which one? We got to use this one, right?
Oh, yeah.
Oh, yeah. Because the others? Cosine, 2 theta. I wish this was actually, maybe we'll do this one as a cosine of 2 theta too. We'll see. We'll see if you guys can handle that much excitement. All right. The sine of 2 theta. We have 2 times the sine of x, cosine of x. All these are multiplied together. And I'm using x where these are all thetas because it's just in reference to the angle. Should be consistent. Very straightforward problem. 2 times. Actually, check with your neighbor. Make sure that they're on this track, or if they're confused how moving that way. Say, hey, this is how you do it. Here's what you missed.
So this is times 0.4.
That's not it.
So you can see here, based on the information given, you would choose one of these. Actually, after this, we want to do our exit ticket, which I didn't do yesterday, but instead of flickers, which is like finger flickers, so A, B, C, D. We'll just do this one too because it has a cosine of 2 theta. I want you to choose which one is best. So what am I going to put in here? 2 times, what is sine of theta?
0.4.
Okay, times 0.4 times
0.3.
equals 0.24, right? No, I thought I heard a bunch of different numbers. Where did that 3 come from? All right, you guys are like waiting for the crux of this, right? Like, where does it get tricky? Okay. I want to just try this last one here, and then I will let you work on classwork for about 17 minutes. If the sine of theta is 0.17, what is the cosine of 2 theta? So this is where you have to choose from one of our 3. Don't say it. You're going to choose from one of the 3. It's pretty straightforward to work out. Okay? Do that one. Share it with your neighbor. You got 3 to choose from. Cosine 2 theta. All 3 of those. Yeah. Here's the problem. Remember PEMDAS when you're working that out. The same PEMDAS is going to apply. So multiply or exponent first. Okay. All right, so we're doing the flicker right now. And let's move this. See it? Yeah. Who needs another 30 seconds to work it? Good. Take your time. Oh, I haven't worked this one out. Let me see if my TA put it on her notes.
Oh, wait, that's not what
Where I can see it on her.
So, no G.
Let's see. There's a lot of it You guys make eats.
So you're gonna have
Strong T. E 0.1.
that explains
It was this close to compliment, guys, and he just ruined it.
You guys are like, I got All right, let's see the flickers, and we'll work it out together real quick. Flickers, give me, so this is the only finger you can use for A. Okay. Give me A, B, C, or D. Wow.
Wait, what? Can we do this?
I know, I have a sprained finger, and since November it's been messed up. I should be taped to it. I keep getting taped. All right, give me some letters. Okay. You have to say wait one more time, then I'll wait. Perfect timing. The answer is A. A? Okay. Oh. 4 is D. Okay. All right, let's do this one real quick. Let's see. Well, Luke, you just worked it out, so how'd you do it? Which one did you choose?
Put me on the spot here. So I chose cosine 2x equals 1 minus 2 sine x squared. Yes. I chose the last one.
Well said. Well said. All right, we're looking for the cosine of 2 theta, so we have it set up. Everyone okay with having x instead of theta? I'm just talking about the angle. Okay, so we're looking at that. Let's see. Sine of theta is 0.17. So watch your order of operations here. I'm going to split it up a little bit different. So we have 0.17, and then we have to square that. You see? Because the sine of theta is this value, we square it first, right? MDOS, exponents before multiply. If you square this, nope. Anybody have it? Square it and then multiply by -2. It looks like you're going to get 0.06.
Something like that.
Yeah. And then that equals 0.94 when we subtract it. So here the cosine of 2x, 2 theta. We get it. Okay. Totally get it? How we choose the formulas? How do we feel? Thumbs up, sideways, down for this? Give me some feedback, please. All right, that looks pretty good. That looks pretty good. You get. What happened? Did your wrist give away? No. Okay. All right, we got 4 problems, 4 homework. So that's about. You got
10 minutes?
I think you can do these in 10 minutes if you push it.
I can do it in 5.
Challenge accepted. What do you lose if you don't do it in 5?
Well, my sister had me.
Don't give that up so easy. All right. Record. Don't forget to subscribe and don't unsubscribe.